Hi, this is Mr. Goma. In this video, we're going to discuss predicting products of chemical reactions. Chemists are often interested in predicting what would result from mixing some stuff together. For example, if we were to mix calcium and aluminum chloride together, what products would result? What elements and compounds would come out as a result of this mixing? By the end of this video, you'll know the steps in order to predict the products of chemical reactions if you're given a set of reactants. We're going to have three key steps in order to make these predictions here. So let's put them up. Step one is to determine what goes with what. So we're going to want to know, for example, for this reaction here, is the calcium going to go with the aluminum and form a compound with aluminum? Or would it form a compound with the chlorine, or is it going to stay by itself? We'll figure that out in step one. In step two, we're going to determine the subscripts on the products that you've put together. Subscripts are the little numbers that come after the element symbols. For example, in H2O, that tells us we've got 2 atoms of hydrogen in every one water molecule and 1 atom of oxygen. If you don't see a subscript, there's an implied 1 there. Now, one thing about subscripts is that they don't automatically carry over. So for example, we've got a 3 subscript on this chlorine. That does not necessarily mean we're going to end up with a 3 subscript on the chlorine in the product side. Once we've done that, we're going to balance the overall equation. So let's get right to it with our first example. Our first example is going to be one we talked about already, calcium plus aluminum chloride. Well, step one is to determine what goes with what. So let's put that up here. And we want to figure out the letter pattern. So calcium, the first thing we have, that's going to be A, plus aluminum, the second thing, B, chlorine, third thing, C, and then an arrow. So let's pull out our kinds of reactions in order to figure out what A plus BC is. So here we go. If we look on this here, we're going to see A plus BC is pretty emblematic of single replacement reactions. We've got an element by itself, and it kicks out one of the elements in the compound, and you end up with a result like this. Now, the only thing with single replacement reactions, and in fact, replacement reactions generally, is you've got to figure out what replaces what. So does the A replace the first thing, kick out the B, or does the A kick out the C? So let's talk about that right now. All right, so the rules that we're going to apply here are that metals replace metals and nonmetals replace nonmetals. So we're going to have to figure out whether each of these elements is a metal or nonmetal. So let's get a periodic table to figure that out. Here's the periodic table. And the most important thing if you're figuring out metals and nonmetals is looking at this staircase. Everything on the left is a metal. So calcium is in group 2. That's going to be a metal. Let's put an M on top. Aluminum right over here is also on the left. That's another metal. And chlorine over here in group 17, that is a non-metal. So great. We figured out that calcium and aluminum are both metals. And if metals replace metals, then the calcium is going to go into the compound with the chlorine. It's going to kick out the aluminum, and the aluminum is going to be by itself. So here we go. The aluminum is by itself, and the calcium is with the chlorine. All right, so we're done with step one now. We figured out what goes with what. Now we need to figure out the subscripts on each of the elements that we have here. Okay. Now, one thing you may notice is that if we have Ca and Cl together, they're going to be an ionic compound. Just like how aluminum and chlorine are an ionic compound. We've got a metal and nonmetal together. We must balance ionic compounds for charge. So let's go take a look back at our periodic table to figure out the charges on each of the elements in this compound here. Ca is in group 2, so it's going to have a 2 plus charge. Cl is in group 17, it's going to have a 1 minus charge. So hopefully we should be able to see by looking at this that if we have 1 calcium and 1 chlorine, they're not going to be balanced. We're going to have too much positive charge. So we need another Cl minus in order to get a total of 2 minus charge. That'll balance out the 2 positive charge. So we will have Ca, Cl2, and of course we have the aluminum from before. So there we go. So we balanced out the charge, and we've got a good ionic compound here. I'll just point out that the AlCl3 is an ionic compound, it does have a balanced charge because we had to get 3 of these -1 chlorines to balance out the 3+ charge on the aluminum. All right, so we've determined the subscripts. Let's go to our last step, which is balancing the overall chemical equation. So I've got to start a little bit on this here. Let's go ahead and figure out what we got. So we have 1 calcium, 1 aluminum, and 3 chlorines. Over here we've got 1 calcium, 1 aluminum, and 2 chlorines. So let's work on the chlorines. If we put a 2 coefficient over here, then we'll be able to get to at least an even number on both sides. So let's try that. So that will change that. 2 times 3 is 6. Notice we're also going to change our number of aluminums to 2. Over here, we need to get to 6, so 2 times 3 gives us 6, so that means this 3 is going to come up here, and 3 times 1 is going to give us 3 calciums. So let's go back over here, take care of the calcium. We're going to need a 3 coefficient. And now we can last take care of the aluminum. A 2 coefficient will give us that there, and we balance the chemical equation. So we went through the 3 steps. First, we figured out what went with what. We figured out this calcium kicked out the aluminum because they're both metals. Then we had to balance the compound. Ca had a 2+ charge, Cl had a 1- charge. So we got these subscripts from balancing the compound. And last, we balanced the overall equation. So that's calcium plus aluminum chloride. Let's do another example. This example here is going to be NH3 arrow. NH3 arrow. Okay, step 1. Determine what goes with what. All right. So let's again do our letter pattern. We have N as our first element, so it gets an A. H is our second element, it gets a B, then we have an arrow. So AB arrow, 1 compound and then an arrow. Let's see what we get from that. If we look for AB arrow here, well, that's emblematic of a decomposition reaction, where you've got 1 single reactant, and that's going to break apart into multiple products. Decomposition. So in that case, what's going to happen is that we'll get AB forming A plus B, and the separate elements are going to be N and H. So what goes with what? Well, we've determined they actually both go by themselves. All right, let's go on to step 2. And in step 2, we're determining the subscripts for our products. Now, N and H, you'll notice, are both nonmetals. N's here, H is over here. They're both nonmetals. And if we have nonmetals, there's an important thing we need to think about for our subscripts, and that's whether they are diatomic elements. Diatomic elements are common among nonmetals. Many nonmetals are just not stable with a single atom on their own. Let's take a look at hydrogen as an example. It has 1 valence electron. You'll notice when valence electrons are unpaired, that's unstable. Valence electrons on nonmetals like to pair up to form a bond, and that makes it much more stable. So, for example, 2 hydrogen atoms will form an HH bond like this to form an H2 molecule. Notice, this is a diatomic molecule. Di meaning 2, atom, atomic is atom. So 2 atom molecule. This makes these unstable single atoms much more stable as a compound. So many nonmetals do this. Let's take a look at the nonmetals that form diatomic elements. It's actually a number of them. All these nonmetals here, and I'll show you on a periodic table, these ones here. You'll see why I have this order in just a moment. But we've got hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. You'll actually notice, if you're a visual person, these over here look a little bit like a 7. So we got hydrogen plus these over here. So 7 total. What's another way you can remember them? Well, if you like mnemonics, I like this one here. I have no bright or clever friends. So I for iodine, H for hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. So let's take a look and see if our products of this reaction here happen to have some diatomic elements. And if so, we'll have to adjust the subscripts. Let's put out our list of diatomic elements here. And we'll notice that, yeah, indeed, both of these are diatomic elements. So the nitrogen is on the list, and so is the hydrogen. So they're both going to get subscripts of 2. Now, one common mistake that students often make once they learn about diatomic elements is they want to make sure every time they see an N or an H or any of these, they put a subscript of 2. It's only if the element is by itself. For example, NH3 is a perfectly fine formula for this compound here. The nitrogen is not by itself. It's with another hydrogen. It's actually with 3 hydrogens. And so in this case here, it does not necessarily need a 2 subscript. So again, the diatomic elements is only if the elements are by themselves on their own, just like they are here. Okay, so we determined the subscripts. Let's balance the compound, balance the equation, and that's going to be our last step. All right, so step 3, balance the chemical equation. Let's go ahead and get our count of atoms initially on the reactant and product side. 1 nitrogen, 3 hydrogens, and because they're diatomic, they're both going to be 2 and 2. Okay, so let's start out with our nitrogens here. If I put a 2 coefficient, that will give me 2 nitrogens, and also 2 times 3, it will give me 6 hydrogens. So nitrogens are okay. Let's balance the hydrogen. 2 times 3 gives me 6. So the 3 is going to go up here. 3 times 2 is 6. So there we go. So we also were able to predict the products for the decomposition of NH3 here. So hopefully these are helpful. If you'd like more examples on how to predict products of chemical equations, then go check out my practice problems predicting products for chemical reactions. Good luck!